Hi, and welcome to my video on geometric sequence part 2, deriving the formula for a geometric sequence. Let's look at the sequence 1, 2, 4, 8, and etc. Notice that this is 1, 2, 3, 4, and this is T1, T2, T3, T4. So we put that in the table. We have n and Tn. N is 1, 2, 3, 4. And Tn is the value, which is 1, 2, 4, 8. So let's see if this is a geometric sequence. The ratio of T2 over T1 is 2 over 1 or 2. T3 over T2 is 4 over T2 is 2, and the ratio is 2. And T4 over T3 is 8 over 4, which is 2. Or you can look up here and see 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2. And notice if you multiply, the ratio is 2, so if you multiply each term by 2, you should get the next one. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. You're going up by 2. So that means the ratio is constant. So it's a geometric sequence. So let's look at the numbers now. Let's look at the numbers of 1, 2, 4, and 8. So if you look at each of these numbers can be expressed in terms of this ratio. So 1 is 2 to the 0, 2 is 2 to the 1, 4 is 2 squared, 8 is 2 cubed as a power of 2. And notice that we have n. The powers of n are 1, 2, 3, 4. The powers of n are 1, 2, 3, 4. And we have the powers of 2. The powers of 2 are 0, 1, 2, and 3. And if you look at that closely, note that the powers of 2 are 1 less than the powers of n. The powers of 2 are 1 less than the powers of n. So the equation that we have to represent this one could be written as Tn is 2 to the n minus 1, because the powers of 2 are 1 less than what n is. And if we want to, that's the equation. So let's just check now. Let's just check to see if that's true. When n is 1, we have, when n is equal to 1, so we have T1 is 2, 1 minus 1, 2 to the 0, which is 1. When n is 2, T2 is 2 to the 2 minus 1, 2 to the 1, which is 2. When n is 3, okay, but n is 3, T3 is 2 to the 3 minus 1, 2 to the 2, 4. So you can see that this equation represents this arithmetic sequence. Oh, sorry, I said arithmetic had a difference. Careful. This geometric sequence. Geometric sequence is the ratio. Arithmetic sequence has the difference, subtraction. Just said the wrong word there. And if we look at the graph of this is n, this is Tn. Notice that belonging to a sequence, n belongs to the natural numbers. So the natural numbers are 1, 2, 3, 4. So there's the natural numbers there. And Tn is the equation. This Tn is the range. So this is your domain. And your range comes out to be the set of all Tn such that an equation Tn equals 2 to the n minus 1, where n belongs to the natural numbers. So the range has to be the equation that represents it, because again, like here, when you put 1 in, you'll get a 1. When you put n is 2 in, you'll get a 2. When you put a 3 in, for n you get a 4, and that continues on and on. So let's graph. When n is 1, Tn is 1. When n is 1, Tn is 1. When n is 2, Tn is 2. When n is 2, Tn is 2. When n is 3, Tn is 4. When n is 3, Tn is 4. So that's right there. And when n is 4, Tn is 8. When n is 4, going over here, Tn is 8. That's 4, 5, 6, 7, 8 is up right there. And you can see that the graph is dots. It's discrete. The data is discrete. We can't connect them because we are only dealing with the set of natural numbers. It's discrete data. DATA. And just to review that to make sure, because an arithmetic or a geometric or a quadratic sequence are all dots. Okay, let's continue. For each geometric sequence, state the equation. So the ratio is 6 divided by 1, or 6. Let's check. 36 divided by 6 is 6. So this is T2 divided by T1. This is T3 divided by T2. And if we take T4, which is 216, and divide it by 36, we should get a 6. So the ratio of this geometric sequence is 6. So that means the equation is Tn is r to the n minus 1. So Tn is 6 to the n minus 1. And again, if you take n is 1 and sub in, 1 minus 1 is 0, 6 to the 0 is 1. If you plug 2 in, 2 minus 1 is 1, 6 to the 1 is 6, so 2 gives you 6. So we can see the equation is true. And let's do another geometric sequence. How do we know it's geometric? Because we know when we say geometric, we're going to get the same ratio. So the second one is 9 divided by 3, which is 3. The third one is 27 divided by 9, which is 3. So our ratio is 3. So the equation is Tn equals r to the n minus 1. So Tn is equal to 3 to the n minus 1. And again, check. Put a 1 in, you get 3 to the 0, which is 1. Put a 2 in, you get 3. 2 minus 1 is 1, so 3 to the 1 is 3. Put a 3 in for n. 3 minus 1 is 2, and 3 squared is 9, so that's the equation that represents a sequence. So notice all the ones we did so far started off with a 1. What about if it doesn't start off with a 1? Well, let's look at the pattern. Let's go and get a ratio of 6 divided by 3, which is 2. 12 divided by 6, 2. Ratio 24, make that a 24 divided by 12 is 2. So the ratio is 2. But notice that the first term is not a 1. Like when you have a 1, then there's no number in front. But what about these? So let's look at each term. Let's look at 3 and 6 and 12 and 24. So each term is expressed as a power of 2. So 3, and as a power of 2, so this is 3, that's the dot, 3 times 2. And this one, I could put a multiplication sign here like this. And 12 is 3 times 4. 24 is 3 times 8. But the 2 is 2 to the 1. The 4 is 2 squared. The 8 is 2 cubed. But we notice that 3 times 2 to the what power is 0, because 2 to the 0 is 1. So we now have them as each of these numbers in the geometric sequence is in terms of the power of 2. And we notice, as before, the term, which is 1, the power is 1 less. The term here is 2, so the power is 1 less. The term is 3, the power of 2 is 1 less. The term is 4, so the power is 1 less. So really, this equation to represent this could be 3 times 2 to the n minus 1. And if we check that out, notice we can write this down two ways. Tn is 3, and we can use a bracket on the power, on the base of 2. So we're going to either put a multiplication sign there, or sometimes teachers will go 3 dot 2 n minus 1. So you can have a dot here indicating multiplication. That's not 2.2. That dot is up in the middle. If it was a decimal, it would be down here. So you can have 3 times that. You can have 3 dot, or you can have the 2 in a bracket. But most times you probably see it written like this. So that case, notice that 3 is your first term and 2 is your. So that means the equation can be written as that's your first term and your ratio is 2. So if your ratio is 2, that's R, and 3 is your T1. So this is the equation that represents any geometric sequence. Any geometric sequence. Tn is T1 times the ratio to the n minus 1 power for a sequence. So let's use that equation. And the equation, again, write it down. Tn is T1 times R to the n minus 1. So let's find that equation for each of these. So let's find the ratio. The ratio of 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So that means R is 3. And the first term of the sequence T1 is 2. So in that case, Tn, T1 is 2 times the ratio, which is 3 raised to the n minus 1 power. And that's the equation that represents this geometric sequence, because you got the same constant ratio of 3. And try 1. This is a 1 term. 1 minus 1 is 0. 3 to the 0 is 1. 2 times 1 is 2. Try 2. N is 2. 2 minus 1 is 1. 3 to the 1 is 3. 2 times 3 is 6. Looks good. And let's do this one. Again, you can pause the video and work these out. You have 40 divided by 80 is, zeros cancel, 1/2. 20 divided by 40, zeros cancel, 2/4 is 1/2. Ratio, 10 divided by 20, zeros cancel, and you get 1/2. So we have a ratio of 1/2. And the first term is 80. So T1 is 80. So the equation, Tn equals T1 times R to the n minus 1. So T1 is 80 times 1/2. Now, when you got a fraction, it's good to put it in a bracket to the n minus 1. Because you got to be careful. If you did this and left off the bracket, is the 1 raised to the n minus 1 or all of it? So be careful. Put it in a bracket. Then we know the 1/2 is raised to the n minus 1. And let's continue. Again, 6 divided by 1.5. And that 1.5 divides into 6. That's 4 times. And we have 24, which is T3 divided by T2. and the ratio is a 4. And 96 divided by 24 is a 4. So the ratio is 4. The first term is 1.5, or we can call it 1.5. It could be 3 over 2, your choice. So Tn, T1 times r to the n minus 1. So you can have the first term 1.5 times 4 to the n minus 1. Or you can change your 1.5 to 3 over 2 times 4 to the n minus 1. Okay, let's do another one. Let's do a ratio here. Oh, let's make r as the ratio, 18 divided by 27. So 9 into 18 goes 3, 9 into 18 goes 2, but my division is gone a little bit. 9 and 27 goes 3. Ratio of 12 over 18. 6 into 12 goes 2. 6 into 18 goes 3. Ratio of 8 over 12. 4 into 12 goes 2. 4 into 8 goes 2. 4 into 12 goes 3. So the ratio is 2/3. So Tn is, oh, forgot to get T1. T1 is 27. So T1 times r to the n minus 1. T1 is 27 times the ratio, fraction, put it in bracket, to the n minus 1. And if you want to check it, again, put a 1 in, gives you 0. 2/3 to the 0 gives you 27. Put a 2 in, 2 minus 1 is 1. You get 2/3. 2/3 times 27. 3 into 27 goes 9. 2 9s 18. Looks like the equation is okay. And the ratio here is 10 divided by 1, which is 10. The ratio is 100 divided by 10, which is 10. The ratio is 1,000 divided by 100. And notice the zeros all cancel, and you get a 10. So the ratio is 10. Your T1 is 1. So Tn equals T1 times r to the n minus 1. T1 is 1. R is 10 to the n minus 1. And so it's 10 to the n minus 1. Because when the first term is a 1, then the 1 is understood to be a number in front of here. That's like we did in the first pages. Okay, so notice the equation. The equation for a geometric sequence, just to write it down, is Tn equals T1 times r to the n minus 1. So I made up this one to be a little bit different. The outcome is a little bit different. Let me explain. The ratio is 4 divided by 2, 2. The ratio is 8 divided by 4, which is 2. The ratio is 16 divided by 8, which is 2. So your ratio is 2, and your first term in the sequence is a 2. So that means the equation is Tn equals T1 times Rn minus 1. T1 is a 2. The ratio is a 2 to the n minus 1. But this can be changed according to the exponent rules. And let me explain. If I had 3 to the 2 times 3 to the 4, then that's 3 to the 2 plus 4, which is 3 to the 6, because when you're multiplying powers with like bases, you add the exponents. So that's the same I'm going to do here. That's a 2 and that's a 2. So there's a 1 power there. So this is 2 to the 1, add on, n minus 1. So that's 2. They cancel out. That's 2 to the n. So the equation is Tn is 2 to the n. And again, check. That's a 1. So put a 1 here, you get a 2. That's n is 2. Put a 2 here, you get a 4. And that's a 3. N is 3, you get an 8. So this is the equation that represents this. geometric sequence. But it can be simplified because the two bases are the same. And that, sometimes that happens. But if you look back at this for a second, if you look back at this one, that's a 2 and that's a 3. So the base here is a 3, but the 2 can be expressed as a base of 3, but we got to do way more math. So this is the simplest equation. So that brings us to the end of writing the formula for an arithmetic sequence. And if you like my video, click the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.